Every year, lightning strikes thousands of buildings around the world, causing unexpected chaos and destruction in just a matter of seconds. These powerful bolts can hit anywhere, from city skyscrapers to suburban homes, and their impact is often underestimated. The energy from one bolt can reach more than 1,000,000 volts, releasing an immense amount of electrical force in an instant. This surge of energy is enough to shatter concrete, melt metal, and ignite fires, making lightning one of nature's most dangerous phenomena. When lightning hits a building, it looks for the fastest way to reach the ground. It doesn't care what path it takes, whether it's metal, water, or even the structure itself. Lightning will always seek the quickest route to Earth. If your building isn't grounded well, lightning can travel through wires, pipes, or even walls. This unpredictable journey can cause severe internal damage, putting everyone and everything inside at risk. This can cause fires, damage electronics, or harm people. Sensitive equipment can be destroyed in an instant, and fires can spread rapidly, endangering lives and property. Proper grounding is the best way to keep everyone safe. It's a crucial safety measure that every building, especially tall ones, should have in place to prevent disaster. Grounding gives lightning a direct path to the earth, channeling the dangerous energy away from people and valuable assets. That way the energy doesn't pass through the building or its systems. Instead, it's safely diverted, minimizing the risk of damage or injury. Instead, it moves safely into the ground, where it can't hurt anyone. The earth absorbs the energy, neutralizing the threat and protecting everything above. Many people think lightning will never strike their building, believing it's a rare event, or that it only happens to others. But the reality is, lightning is unpredictable and can strike anywhere, at any time. But tall, multi-story buildings are especially at risk. Their height makes them natural targets, drawing lightning more often than shorter structures nearby. The higher the building, the more likely it is to be a target. Even buildings surrounded by taller neighbors aren't completely safe, as lightning can jump or branch unpredictably. Even if a strike doesn't start a fire, it can still do a lot of harm. Structural damage, ruined electronics, and costly repairs are common consequences of a single lightning strike. By grounding your building the right way, you protect people, property, and electronics. It's a simple step that can prevent tragedy and save thousands in repairs. It's a step that every owner of a multi-story building should take seriously. Investing in proper grounding isn't just about following codes. It's about ensuring safety, peace of mind, and the long-term protection of your investment. Some people believe that lightning protection systems stop lightning from striking. That's not true. Nothing can prevent lightning from striking a building. The real goal is to control and safely carry away the energy when lightning does hit. A good lightning protection system creates a safe pathway for lightning's energy. It doesn't block or deflect strikes. Instead, it lets lightning follow a path that avoids causing damage. Think of it like a highway for electricity, leading it safely to the ground. Without this pathway, lightning might jump from wire to wire, or even through building materials. This can cause explosions, fires, or serious injuries. The system doesn't keep lightning away. It just makes sure that when it does come, it won't hurt the building or the people inside. That's why every part of the system must work together. When one part fails, the whole system is weaker. The goal is always safe, controlled movement of lightning's energy, never to try to stop nature itself. A lightning protection system is a carefully designed network that protects buildings from the destructive force of lightning. It has 4 main parts, each playing a crucial role in keeping the structure and its occupants safe. First, there are air terminals, also called lightning rods, which are installed at the highest points of the building. These metal rods are the first line of defense, designed to attract lightning strikes and safely intercept the electrical energy before it can hit the building itself. Next are the down conductors. These thick, highly conductive cables run down the sides of the building, providing a direct and controlled path for the lightning's energy to travel from the air terminals to the ground. Without these, the energy could take unpredictable and dangerous routes. These down conductors are connected to bonding devices. Bonding links all the metal framework and important structural parts inside the building, ensuring that no part is left isolated. This prevents dangerous voltage differences that could cause sparks or fires. Finally, grounding electrodes, often ground rods buried deep in the earth, complete the system. Their job is to safely disperse the lightning's energy into the ground, away from the building and its electrical systems. Each of these pieces is essential. If even one part is missing or not working properly, the entire system's effectiveness is compromised. The air terminals are specifically designed to catch the lightning strike, acting as a safe entry point for the electrical energy. Down conductors then move this powerful energy rapidly and directly down the building, preventing it from spreading through walls or electrical systems. Bonding ensures that all metal parts are at the same electrical potential, so there are no dangerous jumps or arcs of electricity inside the building. Grounding electrodes are the final stop, where the energy is safely absorbed by the earth, neutralizing the threat. If any part is missing, the whole system is at risk. Even a single weak link can lead to catastrophic damage. For example, if the down conductors aren't connected well, lightning may jump into the building's wiring, causing fires or electrical surges. Or, if the grounding electrodes are too small or poorly installed, they can't carry the energy away fast enough, increasing the risk of damage. It's important to see the system as one continuous, unbroken path for the energy to travel safely from the top of the building all the way into the earth. The energy starts at the top, moves down through the conductors and bonding, and finally ends in the earth, completing its journey without harming the building. Each part must be strong, securely connected, and able to handle the immense force of a lightning strike. Regular inspections and maintenance are key to ensuring the system works when it's needed most. Air terminals, or lightning rods, are the first things lightning touches when it strikes a building. These metal rods are placed along the roof and any high points like chimneys or rooftop equipment. They must be tall and spaced close enough so every part of the roof is protected. A good rule is to install air terminals no more than 20 feet apart along the roof edges and peaks. Each terminal should be at least 10 inches tall. Place them on corners and near anything that sticks up from the roof. The goal is to make sure that lightning will hit a rod, not the building itself. It's also important to use strong, corrosion-resistant materials for air terminals. Copper or aluminum are common choices. Make sure each rod is firmly attached and won't move in a storm. Don't forget to check local codes about air terminal placement and height. Sometimes you need more rods in high-risk areas. Air terminals are simple, but they must be installed carefully for the whole system to work. Down conductors do the heavy lifting after the air terminals catch a strike. These thick metal cables run from each air terminal down the side of the building to the ground. Their job is to move the lightning's energy quickly and safely away from the roof. You need at least 2 down conductors on opposite sides of the building for every lightning protection system. For larger buildings, use more. The conductors should take the shortest, straightest path from roof to ground. Avoid sharp bends or loops, because electricity can jump off at corners. Use heavy copper or aluminum cables for down conductors. Secure them every few feet with strong brackets. Make sure they don't touch or run too close to windows, doors, or other openings. If the building has steel columns, the down conductors can sometimes be bonded directly to them. This way, the steel frame helps carry the lightning down, making the path even safer. Always check the connections to be sure everything is tight and free from rust. Bonding is the process of connecting all the metal parts of a building together, creating a network so that lightning can't jump dangerously between them. It's like making sure every metal piece is part of the same team, working together to keep the building safe. In multi-story buildings, this usually means linking the lightning protection system directly to the steel frame or the rebar that's embedded inside the concrete. These hidden metal skeletons run throughout the structure, and connecting them is crucial for safety. By doing this, you create one solid, reliable path for the energy from a lightning strike to safely travel down to the ground, instead of letting it scatter unpredictably through the building. To start, you need to carefully identify all the large metal parts in the building. These include steel beams, water and gas pipes, HVAC ducts, and even elevator rails. Any metal that runs through the structure can become a pathway for electricity. Use heavy-duty bonding straps or thick copper cables to securely link these metal parts to the down conductors, which are the main routes for lightning energy to reach the ground. It's important to make sure every connection is tight and secure, so it won't loosen over time due to building movement, vibration, or corrosion. a loose connection can break the safety chain. Bonding is especially critical in modern buildings, which often have lots of hidden metal parts tucked behind walls, above ceilings, or inside floors. Missing even one connection can leave a dangerous gap. If lightning strikes and finds a gap in the bonding network, it can leap from one metal part to another, following the path of least resistance. This sudden leap is called a side flash. Side flashes can cause serious damage to the building's structure, start fires, or even injure people inside by sending electricity through unexpected paths. If you're ever unsure about which metal parts need to be bonded, always check the building's electrical plans or consult with a lightning protection expert. They can help you spot hidden risks and make sure nothing is missed. When bonding is done right, the entire building works as a unified system, channeling dangerous energy safely to the ground and protecting everyone inside. Every metal part, no matter how big or small, becomes part of a safe, continuous pathway to the earth, ensuring the building stands strong, even in the face of a lightning storm. Grounding electrodes are the final stop for lightning's energy. These are usually long metal rods, plates, or mesh buried deep in the earth near the building. Their job is to spread the energy safely into the ground, where it can't cause harm. For a multi-story building, you need more than just one ground rod. Use several, placed around the foundation, and connect them with thick cables. The more contact the electrodes have with the earth, the better. Moist soil is best for grounding because it lets electricity flow away faster. Connect each down conductor to at least one grounding electrode. All the electrodes should be joined together with a ground ring or mesh if possible. This lowers resistance and helps handle even the biggest strikes. Be sure to check the electrodes for corrosion every few years. If they rust away, they won't work well. Always use approved materials and follow local codes for installation depth and spacing. There are a few common mistakes people make when grounding a building for lightning protection. One mistake is using too few air terminals or placing them too far apart. This leaves parts of the roof unprotected. Always follow the spacing rules and local codes. Another error is using thin or weak down conductors. Lightning needs a big, clear path to the ground. Thin wires can overheat or break. Use heavy copper or aluminum cables and keep the path as straight as possible without sharp turns. People sometimes forget to bond all the metal parts or skip hidden steel inside the walls. This can lead to dangerous jumps or side flashes inside the building. Always double-check all possible metal paths and bond them together. Finally, some systems are not checked or maintained over time. Ground rods can rust or cables can become loose. Make a habit of checking the system every year, especially after storms or renovations. A little maintenance goes a long way. A good lightning protection system is more than just rods and wires. It's a carefully planned path that keeps everyone safe when nature is at its most powerful. Every step, from air terminals on the roof to grounding electrodes deep in the ground, matters. Always follow local building codes and national standards, like NFPA 780 or IEC 62305. These rules are based on years of experience and testing. They help make sure your system can handle real lightning strikes, not just look good on paper. Test the system after installation and every few years. Hire a qualified electrician or lightning protection professional. They can check the connections, look for corrosion, and make sure everything is working as it should. Remember, proper grounding isn't just a box to check for insurance or inspections. It's about real safety for everyone living in your building. Taking the time to do it right now can prevent disaster later.